Hey, so maybe you've heard of this one. I am doing xenon. I'm going to do this a bit differently today. Here's an ampule of xenon that's under extremely high pressure. As something is under high pressure, its boiling point increases. In the case of xenon, under this much pressure, its boiling point increases to about 16 degrees Celsius or around 61 degrees Fahrenheit. As it is warmer than that in here, I wanted to show this first. As with my other gases, low-pressure ampules of xenon can be made to light up when placed in an electrical field, like I'm about to show you. It's a pretty shade of blue. So that's fun. That's a gas cube for my density cube display, and this is, of course, a lucite cube. Like a few others I have done, it is a noble gas along with helium, neon, argon, krypton, radon, and possibly the synthetic element oganesson. As with all noble gases, xenon has a full outer shell of electrons, and thus it really just wants to be left alone. Unlike its lighter brethren, xenon will react with fluorine, which reacts with almost everything, including glass. I'll cover fluorine another time, though. You saw that xenon can be forced to boil at a much higher temperature when under high pressure, but at standard pressure, this is not the case. It melts at minus 169.4 degrees Fahrenheit, and it boils at minus 162.4 degrees Fahrenheit. It has a density of 5.887 grams per liter. Xenon does have some commercial uses, mainly ones that reflect the glow that it gives off that I showed you earlier. It is used in some high-end car headlights and in photography. Some high-end doors and windows contain xenon. The fact that it is much heavier than air means that heat will have a harder time getting through it. Argon is usually used and less commonly krypton. Xenon is much more expensive. It doesn't give much more energy efficiency than does krypton. Xenon difluoride is a strong oxidizing and fluorinating agent that is used to, among other things, etch silicon microprocessors. Xenon is extremely rare in the Earth's crust due to its inertness, as well as its general rarity, but it's also quite rare in the atmosphere. 10,000 liters of air will contain less than 1 milliliter of xenon. It's not super difficult to extract, though. Air is brought to an extremely low temperature, and since each of its components boil at a different temperature, it is simply captured as it boils. It was discovered by William Ramsay and Morris Travers in 1898, the same year they discovered two other noble gases. So that is xenon. I hope you enjoyed this video. See you next time.